Oh boy, here we go. Rant number 2, eta squared versus partial eta squared. All right, there's 2 ways to measure effect size. When we have multiple effect sizes, the effect size, multiple factors rather, the effect size gets a little weird. We saw before with the one factor, just straight up eta squared. Sums a square of the effect over sums a square total. And that makes sense. It's proportion of variance explained, just like you have with regression. It's out of the total amount of variance. Now, if you look at partial eta squared, there's a couple of different representations. You could say sums a square within plus the sums a square, the effect, or you could say sums a square total minus those 2 effects that we're not considering, sums a square A and sums a square B. That subtracting out piece, that's called statistically partialing, taking something out. So that's where partial eta squared comes from. The problem in moving from eta squared focus on variance explained out of total to partial eta squares, variance explained out of what wasn't explained by the other effects, means that this partial eta squared statistic isn't really anything logical that we would think about. Total variance explained. Yeah, okay, we know what a percentage is out of total. Total out of whatever wasn't accounted for by the other factors is a much more slippery concept. And just to be blunt, I really find partial eta squared stupid. It leads to odd results. We can have 3 partial eta squared values that add to well over 1.0. So if you're thinking about it in terms of percentages, it would be more than 100%. Eta squared ain't going to do you like that. Partial eta squared is also not comparable across research study, across different studies, because it depends on the other factors that are in the study. To me, the main point of effect size is just to have something that allows for comparisons across studies. So if we don't have that, then what good is the measure of effect size? Now, this isn't just my opinion. This is a general opinion about all partial statistics. In fact, I'm on this very large project, which has something over 100 authors on it. And we just completed a manuscript. And I was reviewing it, and they were using a statistic that's analogous to partial eta squared. It's called partial correlation. And I was arguing that it was not the right statistic to use for this very reason. And all the other quant folks on the project jumped on that and said, yeah, this is a bad measure. All right, so why do we use partial eta squared if it's so bad? Sometimes the reason is not a good one. It's just that everybody else does that. It's easier to go to the path to least resistance rather than to actually figure out a better measure to present. Also, it's the defaults in many statistical packages. And when you have people just taking blindly from a statistical package, looking at USPSS, and grabbing statistics there and slapping them into their papers and not knowing what they mean, just knowing that they have to provide a measure of effect size, you're going to have issues.